Okay. Hey, everyone. July 16, 2024. This is the 64th meeting, if I count correct. And thank you for joining me. We'll have about 50 minutes today. I prepared a few things, hopefully interesting. If you are new, uh, hi, thanks for joining, and hopefully you'll have fun. Uh, what what do we do here? We meet every month just to share ideas and talk about C++. I do my best to bring things that are uh, interesting, applicable to whatever you do with C++ on your daily basis. I think this is important, and just hopefully you'll end up learning new things, at least one thing, but hopefully more. So this is the agenda. We have a new C++ book that was published. I have both the soft copy from Pragmatic Programmer and I have the hard copy. I just received it like a couple days ago. It's very thin, but super fun to read. I went to Toronto with family for a few days, and half of the book was on the fly there to Toronto, and the other half was back. So not the entire flight, just a few hours each time, and it's really fun. So that's one thing. We have three chapters that are publicly available. So I took that as an example. I highly recommend looking at the book. And then we'll discuss about destructors that are throwing. We'll take a look at use case, what to do, what not to do. And I'll end up with a how to find bug uh, that I just noticed in few code bases in the past month, just separately in few places that. So I thought this is important enough that I'll show it and people can identify the pattern and think about it when they uh, review code or write code. So just the regular stuff. We have a Dropbox link. Hopefully you can access that. Let me know if you don't. If you want to join the Discord, I have a link for you. Just ping me either in Meetup or either like LinkedIn or whatever. Uh, we have a channel on YouTube that I'm uploading the recording. SDCPP Meetup Twitter handle, and my Twitter handle is Kobe_CA. I tweet about C++ and other stuff related to C++, basically. Also Python and Rust and similar. My name is Kobe. I was a technical reviewer of a very nice book by Dorothy that you can see on the screen. You can find CPP cast episodes on the web. I work for NVIDIA. So let's start with the first item today, which is the book that I mentioned. So C++ Brain Teaser by Anders. I think he resides in Europe. I can't remember the state or the country in Europe, but he resides in Europe somewhere. This is a very nice. I told you it's a thin book, 25 puzzles. What I really liked in this book is that every puzzle, it's not like crazy puzzles or anything like that. Well, some of them are kind of uh, a bit more on the advanced part, but the nice part about this book, and I gave the author a feedback, a very positive feedback, that he spends a lot of effort to explain what exactly is happening. So it's not just a puzzle book with the results of what does the program do, but it's also a lot of effort was spent in explaining what exactly is happening, what are the rules. So it's actually like a reference book for all kinds of very applicable use cases. Um, yeah, that the last part here. I don't know if you can see my you can see my here. So this is the last puzzle, and it is kind of funky, but there's a lot of, even if it's a bit crazy, puzzle, you learn a lot about some of the rules that you might be bumping into when reading or writing code. Okay, so each puzzle is complete. You don't like it's not in a specific order. I don't even think that there is like some uh, order of difficulties or anything like that. So it's really up to you. I just read it cover to cover. It is you're expected to know about C++. Like if you're completely fresh, it's gonna be tough because it's not really easy, in my opinion. And by the way, here, Programmatic Bookshelf uh, has this gouge where they tell you this is more towards the expert level, and I agree here. Um, so yeah, this is a very fun and it touch a lot of subjects. So as I mentioned, if you go to the website, as I mentioned, I was purchasing uh, both the um, ebook and the printed one. The ebook, I actually purchased the early access one, and you get like snapshots. So this is just like Meep in Manning and other. So you get snapshots. So there was an option to do that as well. So I suggest if you like a book and you want to see snapshots early on before it's published, that's an option. Okay, so 2, 3, and 14 are there as an example. So I use them to demonstrate the power of the book and hopefully convince you to take a look at that. So let's start with 2. So this is the first one. You need to try to guess, just guess what is the output of that uh, snippet of code. And what I didn't mention is that just like we have in CPP, the CPP quiz from the website, there are a few options. Either it's printing something, or it's undefined behavior, or compilation error, or it's implementation specific, implementation defined. So there are a few options. So what do you think happens here? You can scream, shout uh, the answer. Would it compile? So we have a serialized. It's overloaded. We pass a character array, uh, and it's either going to pick either might compile a warning. Someone said, okay, that's one option, but it means that it's if you compile with error, so it's gonna be compile error. But let's so compiler error warning is one option. The other option is it picks one of them, so there's no ambiguity.
I'd say no, it's not going to compile.
Okay. Any
I would,
other?
I
Yeah.
would guess that compiles with the const void star, but I mean, I'm not 100% sure either, but I think unless you suffix the hello world argument with an S, it would be interpreted as a C style string, and therefore the first one. But I don't know, not positive.
Okay. So this is just the second puzzle, but I would argue that this is not an easy one. Um, it is going to compile. It's actually very defined, very valid, and all. It's going to be const void pointer, just like Dominic mentioned. And so there is explanation, and we'll go through the explanation. So here's the okay, 1 second. Uh, a sec. Sorry, I'm gonna reshare that. Okay. So there is an explanation about what's happening, and I'll give you the short version of that. Basically, the compiler is building the available overloads. Like it needs to pick, and eventually it needs to pick the best match. And so, what is the best match? So obviously, uh, a, an array of characters is basically a pointer to char pointer, a const one in this case. And so we have the const void pointer and we have the std string. Now, the the idea behind std string accepting this const char pointer is that there is actually a constructor which is non-explicit constructor that can take that as a parameter and create a temporary, which means there is a user defined conversion from a char pointer to a std string, but it is a user defined conversion. On the other hand, there is also a very defined conversion from const char pointer to the void one, to the const void pointer. So the question is like, what is better? If they are equally good, it's going to fail. But if one is better, then it's going to be picked. And the long story, making long story short, is that the if and this is something that I memorized many years ago. When I look at the code and I need to understand what's happening, is that if you have a user-defined conversion versus something that doesn't involve in user-defined conversion, like primitives conversion and all, the user-defined conversion are less preferred. Okay, so let's take a look at now. So this is basically the very short version. So let's take a look at what the book is saying. So if you have 1, 2 and you have int, and float int, what do you think would happen? So the first overload has a better conversion for the first argument because int is better than int float, and no worse conversion from the second argument, which int on both overloads. So basically, it would be used since there is a better conversion. So let's take a look what happened next. What happened next? This is basically what I just explained, but in diagram. There is no constructor conversion. Yeah, someone says this is a poor style to write code which causes reader to be unsure. By the way, I agree here. I think there is a comment in the book where it says that this is not encourage you to confuse people. I'm completely with you. But the idea behind such puzzles is just to highlight something that we might not really be aware of. So yeah, don't write code that confuse people. By all means, this is bad. But we just take such opportunity, just a very cooked up example, just to understand rules of the language. Sometimes they are kind of very I don't know if esoteric is a good word, but because I don't know how esoteric it is. It's actually used a lot. This whole overload resolution and the mechanism is really important. Just like ADL is important, right? So there is no user constructor conversion in the first one. So it's a standard conversion. No object created. But the other one, there is an object created. So we need a user-defined conversion. It's less preferred than the first one. So that's basically the gist of it. So further reading, there's few links. By the way, yeah, in every puzzle there is a page for further readings, which I recommend just to be familiar with. So if you need to go back and take a look, string literal, Dominic mentioned that if you bring the string literal namespace and have s at the end, this is going to be a string, and this is going to be a preferred one. Then std string, there's for the constructors, that's a good one. An overload resolution, in CPP reference. Also a good place to read about their rules. Okay, 3. What do you think happens here? So 2 functions, they look identical. One is initializing ID with get user ID. One is not initializing ID, but it's using ID. If the ID is 1337, there is a print. Otherwise, there is no print. So what do you think happens when we call these 2 functions?
I mean, undefined behavior.
Undefined behavior. Well, it's undefined behavior. You might get some output. This is one option that the book highlights. Possible, but obviously undefined behavior, everything can happen. So what really happens here? So if you know, and this is what I like in languages like C and C++, you have the opportunity to learn how stack is handled, how the heap, what is stack pointer, what happens when function returns, obviously optimization and all, scramble the things, but you have opportunities to understand. So this is basically if you know how stack is working and all. So yeah, so when we call one function, uh, there is some location on the stack that is populated with 1337 return. Second, someone wants to enter. Let's read it. And then it returns, but the value is still there. And we call again, there is the same layout. That's what basically what this is trying to say. There is, it's just, I don't know if you can notice that, but it's kind of a fade. It's not really as solid as the first one. Just to show you that there is a value. In this case, it's a single threaded, no funky stuff. Probably no one is stomping on the stack. You might see 1337 still there. So this is why. But it's undefined behavior. It's uninitialized. We're using it. We're referring to it. It is it is undefined behavior. Period. Uh, Avoid doing that. Sanitizer is one way, and this is some recommendations. So sometimes we have recommendations. Yeah, every good compiler will report a warning. This is true. So enable warning, all extra pedantic. I do my best everywhere to have warning as error, so it's really hard to ignore it. Uh, I really like working with IDEs that have built-in um linters like Clang Tidy. Uh, I really like working with C-Line just because it's all battery included and all. So I just fire up the IDE and I have everything there in front of me. So if I make a mistake, it's right there. So Clang Tidy is running always on the background. We'll talk about it towards the third part of the meetup. Enable warning is errors, sanitizer. So make sure you have a sanitizer build. It's a special, if you use CMake, for example, you have a special either presets or whatever that allows you to build that. If you have a version of C++ command that have a garbage collection, not something that I'm aware of. There was some proposal some time back, nothing happened. There is no GC, no, that I'm aware of. Further reading, undefined behavior in UB, in CPP reference, and there are a couple of others, like Google sanitizers to read about sanitizers, and we'll talk about it again towards the end of the meetup. There is another item related to bugs. Remember the third item. Okay, 14. What do you think about that one? So this is one of the puzzles that I think super important just to understand how the language, and we say C++ basically inherited that from C. The whole idea of this puzzle is the following. is same v, which is basically a type trait compile time type trait that tells you the underscore v is just a synthetic shorthand to colon v value. If character 1 plus character 2, the decal val of this expression is the same as character. And someone says, oh, so some say, is it promoted to integer? So if it promoted to integer, it's not the same as character. And I didn't catch the name of the person that it, I see it in a small tooltip. So the person is correct. It's 0, which means is same v is false. So the book has few pages just talking about integer promotions and what exactly happening and what exactly the rules are, what are the guarantees. Like it talks even about all kinds of very strange or weird architectures where maybe a byte is not 8. So all of that is discussed in details. So I highly recommend it. This is an example from pragmatic programmer uh, page. So you can go ahead and read about it. It's few pages long, very detailed, explained very well. So yeah, the idea here is that there is an integral promotion. Character plus character is not going to be a character, it's going to be an integer. And there is all kinds of rules about unsigned and so on and so forth. I highly recommend to just read about it. Further reading, Shafiq's pages are always good to read. What else is really good here? Integer promotions, also very, very good to kind of understand. I really like this. Like every time I have an item about integer promotion, I point people to Dan Sachs. This is Code Dive 2018. And in my opinion, one of the best, there's a lot of very good talks out there. This is one of my favorite. I think I changed the way I read and write code thanks to this talk. Yeah, yeah, I agree. Someone mentioned about good style. So mentioning the width and all. He talks about it, by the way. Dan Sachs talks about all of that. This is, I think, 1 hour long, worth every minute. Yeah, thanks for posting that. Again, I'm not kidding. This is one of the talks that changed the way I write code, read code. There is also a book about can't remember the name. I'll post towards the end. It's just about C and C++ safety. It's a kind of a thick book. I can't remember the name, but it also talks about all the integral promotions and all, which I really like. But it talks about other stuff, and it's kind of a very, very important book for us. A lot of stuff we inherited from C, just like that. So let me just admit people. Okay. So this was just the three items from the book. Again, highly recommend. Take a look at that. Super fun, learning a lot of things. So let's talk about throwing destructors. Just the discussion. We'll look about a use case. And the reason I'm bringing that up here is because this is not a theoretical issue. This is a real thing that we need to address in our code base, which we need to understand what's happening when you write destructors, what happens if you don't pay attention to what you have written in your destructor code, like in the definition, what happens if it throws. And a nice use case about this exact uh, topic. So let's start. So let's talk about rules and facts. Just kind of not a particular order, just to uh, uh, get the stage ready for the use case. So C++ 11 has few rules about throwing destructors. I just want to mention one important thing. Std swap is counting on the fact that if you have a throwing destructor types, you kind of lose the exception safety guarantee of std swap. So kind of an incentive to make sure that your destructors do not throw. We'll see some exception to this rule. Most likely you're not going to do that a lot, if any, in your career, but just it's just there if you, in case you need to. If you do happen to have code that throws exception from a destructor, you are in danger area to have a std terminate invoked. And the reason is pretty obvious. Think about a exception that being thrown and there is a stack unwind. So what happened is that we start destroying things on the stack one by one, reverse order, and we call destructors. So we have an exception context right now, and we call a destructor to destroy a specific object on the stack. And let's say it's a user-defined destructor, and destructor is throwing. What do you do? Which context, which exception context are you going to do now? There is no nesting in this case. So so std terminate is being invoked. So first of all, be aware that you are going to have that happening if you're not careful. In C++ 11, destructors are implicitly defined as no except, or no except true, which we'll take a look at in a second. Even if you throw from your destructor, it's still no except, and then std terminate is being called. So by the way, this is true for a lot of, not a lot, like all the function that is marked as no except or no except true, and you're throwing from that function std terminate, because you have a guarantee that is not going to throw, and you still throw, so std terminate would be invoked. And sometimes you want that. We'll talk about this as an exception, but usually you don't. You need to specify it as no except false, or inherit from a type that has it, or you have a member that has no except false. So this basically means something very simple. You have no except, or no except true by default. C++ 11 guaranteed that. But if you inherit from something that has a throwing destructor, it has a no except false defined, or you have a member, then your destructor is now a no except false. Just remind that. There are a few good reading blogs. I just mentioning one of them. Just think about what happened when you throwing for your destructor, your object cannot be destroyed. So if you have something very special that you need to do in your destructor and it's not happening, or you have a cascading effect of other things that needs to happen, and throwing for the destructor might interrupt this flow. Think about it. This is unexpected, and people don't like to be surprised. So think about it. Unfortunately, there is such issues in production code. It's usually not really intentional, by the way. It's just we call a function that has a throw, and in some use case it's throwing, and we didn't protect that, and it's escaping from the destructor. It basically means the destructor is throwing, and then std terminate is invoked. I've seen that. Not intentional. People don't do that intentionally. So what I noticed, I can't remember where exactly. I need to find it again. But core guidelines, I think I saw it core guideline in the core in C++ core guidelines, a sentence or something that or paragraph that says, look, if you want to abruptly kill your program with to terminate, yeah, you can throw from the destructor. Just document that this is intentional. You're throwing from the destructor. You're killing the use to terminate, which basically calls to the abort. This is the handler by default. Uh, but don't just document that. Just make sure that you understand that other destructor would not be called. Some implication, some negative implication on any graceful cleanup. There is a different discussion. I'm not talking about what happens when you use std exit somewhere in your program within your logic. I personally don't like std exits that just out of nowhere from the middle of your program. The automatic variables are not being destroyed. The global scope, yes, on namespace scope, but not like static storage, but not the one on the stack. So sometimes you do want them to be destroyed. So std exit is not, in my opinion, I don't really like that. Okay, so let's take a look at something tangible, something that actually is a real use case. This is from a Stack Overflow, someone posting an issue from that actually happens in TBB, Intel thread building blocks. It's a very famous library. I think one of the compilers, is it Clang, that is using it for their, can't remember if it's Clang or GCC, using it for their parallel algorithms. So think about my object as an object from just like TBB that throws. So it has no except false. So this is one object, and I'm aggregating that in B, and I have inheritance from A. Okay, so let's kind of digest what's happening here. So we overriding the regular or traditional the rules of no except true. So we override that. Basically, you have uh, an object that is going to throw. It's just saying that I'm going to throw, and then I'm inheriting from that. So even though I'm inheriting, this is still no except true. But what happened is that my object is going to throw, and I'm getting this error that exception specification of overridden function, which is basically this factor. That's the only one that we override here, because this is virtual and this is basically more lax than base version. Basically, that's the, if we want to take a look at what's happening, this is the actual error. It's an error. It's not a warning or anything like that. So again, we have a no except true, which is the default. And what happened is that B, because we have an aggregate of something that has no except false, become no except false. So think about a user that holds A. It's a polymorphic use case, holding A, and it's no except true. Basically, the destructor is no except. Now I'm pointing to a concrete object of B. I think what happens here is that the guarantees are not, they are kind of violated. Like as a user holding A, pointer to A, I have a guarantee of a specific virtual function, which is the destructor, but which says I'm not throwing, but the one that overrides it is throwing. So this is a compile error. And again, this is throwing because my object is throwing, just like I mentioned in the previous one. So this is just recap. Destructor I by default no except true. This is C++ 11, unless you have a member that can throw. So this is why B is becoming a no except false on the destructor. So virtual A is actually virtual A no except or no except true. Does not match virtual B, which is a no except false because of the member. How do you address that? So there are a few options. We'll talk about what can we do in order to mitigate that. So one option you mark B as no except true. Basically, you overriding the no except false that we kind of inherited because of the member. Okay, so if my object grows, we're gonna have to terminate because on the B boundaries because we said no except true. We're not going through exceptions. So on the boundaries of B, we have to terminate. So that's one option. Not the best option, but it's one option. You can mark A itself as no except false. So then it matches everything that is deriving from A. But it's a bit ugly. But there are other options. Basically, I'm going to show you two options from the that are kind of equivalent. Both of them basically masking that. Okay, so this is the one. This is the first option. One of that. So you take my object and you wrap it. So this is my object, and you wrap it with unique pointer with a deleter. So when the destructor is being called, we're deleting the object. If something is thrown, we're catching that. Meaning, basically, this is basically how you make sure, in a very simple way, that your destructor, no matter what I'm calling, we're not going to bubble the exception up to the caller. So this is real true, no exception, no except true. Okay, so this is one option. The original posting was also submitting a specific answer, accepting that. Basically, the same idea. You having a try catch and making sure that nothing is escaping from the destructor. It's a very simple and frequently used technique, by the way, just to make sure that I don't know what's going to happen. I don't even, I might not even uh, uh, trust the API that I'm invoking from the destructor. It might someday throw, and I want to make best hygiene of my destructor. So this is one option to make sure that it's not going to escape from the destructor. So these two are the same idea. So I have a link for that. It's although it sounds very niche, kind of a topic, it's actually super important, and I've seen that happening in production. So it's not really something small that we should overlook. It's something that is really important. Yeah, and core guidelines, which I really like to go and just read what Herbstadter and Bjarne are thinking, and other on the that maintaining this this document. I highly recommend have that tab open if you have any questions about like what are the guidelines. Obviously, guidelines are guidelines. You need to tweak them with proper documentation of why you're tweaking them. The cycle must not fail. It should be no except true. There is some point in the guidance when it says, yeah, if you really want to terminate this, yeah, just throw from the destructor and kill the whole thing. I rarely see that as a solution in production code, by the way. People try to be nicer here. So this is what we actually saw in the example. Detail X happened to have a throwing destructor, which means that implicitly X destructor is no except false. If in doubt, if you basically what this guidance says, mark it, because things might change. Someone would in the future stick a member in this class that happened to have a throwing destructor. Think about TBB. It's a serious library, I think. And then your no except, your implicitly no except true becomes no except false. So what they say is like have it maybe if you're kind of paranoid, have it explicitly mention, which is might be a good idea. Um, a simple a destructor should be declared no except if it could throw, and then obviously no except true would terminate that. Um, yeah, why not declare all these factors no except, like explicitly just clutter? The problem with C++ is like when you start adding all the like no discard and override and cons and all that stuff, there's clutter, and you need to remember all of that stuff. It's kind of a pain. But yeah, I'm just the messenger here. Okay, we are basically the last 5-7 minutes of the meetup. Kind of another hard to find bug that I just noticed in the past few weeks in few different libraries, and I wanted to bring that up in for the group. What do you think is wrong here? Creating a string, taking the CAE which gives me the const character pointer. I assign it.
Isn't that a temporary?
It is a temporary. What happened to this temporary at the semicolon?
It gets destructed.
It dies. It dies. This is kind of this is undefined behavior. It's a very scary one, and the reason it's scary is because I've seen that multiple times. If you are using tools, do not fear. You have the tools. By the way, this is why I think that we should use the tools as much as possible. It saves a lot of debugging, a lot of headache, a lot of tears. If I try to run it, what is the compiler that I'm using? Did I make a note here? This is released. It's the same release with debug info. The reason with debug info, basically, it's just O2. This is O3. So this is the output. The output of such undefined behavior is glib cxx, which is like, yeah. I didn't realize. I didn't think that it's going to be glib cxx, like, but this is the output in optimization. Same for that. Nothing with Valgrind. By the way, I didn't get a chance to get Valgrind saying something. It's actually saying hello world, which is kind of weird, but okay. Now,
That's very weird.
yeah,
Not just kind of weird. That's a
yeah,
use after phrase.
yeah. I agree. Maybe I did something bad. I don't know, but yeah, if someone wants, it's a very simple code to kind of put in your IDE and or VI or whatever. Sea Lion. So Sea Lion has two modes. It has like the clang tidy mode. Sorry, JetBrain, if I not really completely accurate, but there's a clang tidy mode and there is the reshopper Nova mode, which should be faster, more advanced, and all of that. The old non-reshopper, so when I say old, the just clang tidy, or whatever the engine that they use on top of that, actually tells you that this is an issue. You can see that in the tooltip. It makes this line. It says this is not a good thing. So that's basically why I don't know why reshopper engine doesn't say anything. Unfortunately,
I
there's
don't
some
see why it lets you go past that. That's like that's like not worse than not a good thing.
yeah.
Like,
So
this is not going to do what you think.
yeah. So this is actually, but it's nice that it gives me this error. So this is what in the advanced settings of CLI it says use reshopper language engine, which is basically CLI and Nova. Someone says address sanitizer finds it. Yes, true. Yeah. Otherwise, we'll be. Yeah, we would move to C sharp. I don't know. If other sanitizer doesn't find it, I'm ending the meetup. That's it.
Does
So
I think
Don't I
Valgrind.
want to get back into C++.
yeah. So
I mean,
honest, yeah, it's fine. It finds it. Yeah.
I think Valgrind would. I mean, that string wasn't actually going to be allocated on the heap, so maybe
Yeah,
I
it's
forget whether
true.
Valgrind catches
Yeah, good point. Let me take a look.
might be the reason.
Let me take a look. It's too short.
Yeah.
SSO kicks in. I think you're right. Let me retry that and post it in the Discord if I find something else because I really want. Okay, we have sanitizers, so we have something that works. We have Sea Lion, at least not the resharper that works. Uh, but let's see if I can make the other one, the background one, to work. Okay, but that's a good point. Yeah, that's a good point. That's it. That's what I had for today. Uh, hopefully you learned something new, at least one. Um,
What I've
and
learned is after 30 years of C++, I still get operator or function overloading wrong. And that void star eats almost everything.
Okay, let me tell you something. So I tell my wife that I memorize a lot of things in C++. And this is my excuse why I can't remember things that she's telling me, asking me and all. Fortunately, C++ is only growing, so my excuse would hold for a very long time until my retirement, at least. So I memorize a lot of things. Like, it's really like, and I don't even know everything because it's hard to memorize and there's a lot of corner cases. And really, take a look at this book. If you just want the ebook is not expensive. Uh, and you'll be surprised how many things that you read on the like overload is kind of a very kind of basic stuff, but there are some corner cases that you might want to know. um so this is why I started with this book. I really like this short books with either good like a best practice ones or here's things that you should be aware of, and a lot of good explanation that you feel really good after reading such books. So yeah, hopefully I made a good service to the author, and you'll go and grab it. Link to Discord. Yes. You know what? If you just hold a second, I'm gonna just post it here. So if you give me a sec, I'll do that. Just give me a sec, and then okay. I'm gonna just get a refreshed link and just post it here on the chat. Okay, got it. Okay. Okay. Invite people, copy, paste, go for it. Okay. That's it, folks. Thank you for joining. See you next month. Uh, take care.
Thank you, Kobe.
Bye bye.
Take care. Bye bye.
Thank you.